All right, in this video, we are going to talk about the fundamental Pythagorean identity. So, an identity is an equation that is true for all values for which it's defined. So, in other words, if you plug any number into it, then you will, any number for which the expressions are defined, as long as it's in the domain of the expressions, then you are going to get a true statement. Okay? And so there's a lot of these in trigonometry and pre-calculus that we're talking about, and so but this one is kind of the fundamental one. It's one of the most basic ones, and one from which a lot of the other identities follow. All right, and so it basically comes from the equation of the unit circle. So remember, at the very beginning of this section, we started talking about the unit circle and its equation, x squared plus y squared equals 1, right? And then we talked about how to find the value of cosine and sine. And we did that by locating, right? For any real number t, we drew an angle in standard position that had a radian measure t, right? And we looked where the terminal side of that angle cut through the unit circle. And the x coordinate, or first coordinate of that point on the unit circle, was the cosine. And the second coordinate, or the y coordinate of that point where the terminal side cut through, was the sine. Okay? So that means that these cosine sine pairs are points on the unit circle. That means they satisfy this equation. So if I plug the cosine in for x and the sine in for y into this equation, I get cosine squared plus sine squared, or I should say cosine squared of t plus sine squared of t equals 1. Okay? And so that is true for any real number t that you want to plug in there. If you take the cosine of t and square it, and then take the sine of t and square it, add those two things together, it will always come out to equal 1. Okay? And again, the reason is because these cosine t and sine t ordered pair is a point on the unit circle. So it has to satisfy the equation of the unit circle. All right, so this is the fundamental Pythagorean identity. Cosine squared t plus sine squared t equals 1. All right, so one thing to note about this is that this notation here, this squared notation, okay, you notice how it is in between the name of the function, which is cosine and sine, and the function's argument, that part in parentheses and the variable inside there. So that is something that you may not have seen before. If you have seen it before, it was probably in conjunction with logarithmic functions. But again, you may not be used to that. So this notation is just basically a shortcut for a longer way of writing this function. So I already have this problem written out on this, but I'm gonna go ahead and write that out. The explanation here a little bit lower, and then I'll erase it. So when you write something like cosine squared t, right, what it means is it is the same as cosine t times cosine t. All right, when you take the cosine and multiply it together. You can also write that like so, and I'm going to write this with brackets so it's a little easier to see. Right, when you take an expression and multiply it by itself, it's the same as squaring it, right? Oops, sorry, I wrote an extra. This 2 shouldn't be in there. So it's the same. So cosine t times cosine t is the same as cosine of t quantity squared. All right. So one issue with writing this notation, you can see it takes an extra set of parentheses here. Okay. I always tend to write the parentheses on these expressions, but sometimes you don't. Sometimes you'll see people write it like this, cosine t without the parentheses. And so if you want to write cosine of t quantity squared, you can't write it like this, okay, because that's ambiguous. When somebody comes along later and looks at that, they don't really know if it's the cosine of t being squared or just the t being squared, okay? So a lot of times you'll see people write it like this, like so. That would be acceptable. And now people would know, okay, that means cosine of t times cosine of t. The other way that you would see people write that is like so, by putting an extra set of parentheses around it like that. And now that means that this is cosine of t times cosine of t, okay? So I always, again, when I'm teaching this, I just like to put the parentheses around the argument. I don't really like this notation when you're first learning this, right? Because people lose sight of the fact that it's like the f of x notation. That's all this is. It just happens to have a 3-letter name instead of a 1-letter name. So to me, I always try to put the parentheses around here so people will hopefully make the connection, right, that this notation is exactly the same as this. Okay, so if you do that, then you can see that this is writing cosine squared this way. Kind of takes an extra set of parentheses, which is a little annoying that you have to write an extra set of parentheses. So when you write the cosine squared in this notation, right, then it's also unambiguous, and it saves an extra set of parentheses. All right. So this is one good thing to keep in mind, that cosine squared t, right, means, these things. It means the cosine of t, the whole thing, times the cosine of t, times itself, or like this. So this is basically just a shortcut for writing certain expressions where you're squaring out these trigonometric functions. Same thing with sine squared t. Okay. All right. So that leads us into the problems that will work in this section. These problems are important because we'll see a lot like these. So I'm going to do this example that I have written up here, and then I'm going to do another video with another example, a different example in that one. Okay. All right. So looking at this problem here, we are going to, let's see, what does it say? It says if the cosine of t equals 1/7 and t is in the 4th quadrant, then we want to find sine of t. Okay, so we're given the cosine t and the angle that the quadrant in which the angle is located, and we want to find the value of sine t. So first thing to do, right, is to kind of draw this out, draw this angle out, and it doesn't have to be perfect, right? The angle is going to be in standard position, right? So the vertex is here, right, and the initial side is pointing in the positive x direction, and we know that this angle is a 4th quadrant angle, right? So that means that the terminal side is going to be down here somewhere, all right? So I don't know exactly where it is, but that's all we need. Okay. So, and remember, the sine and cosine are going to be some point, or the coordinates, right, of some point on that terminal side down here. And the thing that we need to know, why we need to draw this little diagram, is we need to know, we're after finding the sine, we'll need to know whether it's positive or negative, right? And so in the 4th quadrant, right, if I have any point down in the 4th quadrant, I get there by going in the positive x direction and the negative x direction. So I know that the points down there, right, have a positive first coordinate and a negative second coordinate, okay? And we're going to have to keep that in mind for later on in this problem, okay? All right. So going back up here, right, I want to find the sine, so I need some kind of relationship between cosine and sine, and of course that's going to come from the fundamental identity, right? Cosine squared plus sine squared equals 1. Okay? Like so. And so now I know what this cosine is, right? The cosine is going to be 1/7, right? So I'm going to replace cosine with 1/7. Remember, this is cosine squared, right? So cosine squared would be 1/7 squared, all right? So don't, sometimes you'll see people drop off the square, right? Because they're a little unused to this notation right here, but don't forget to keep that in there. All right, and sine squared, we don't know what that is. That's what we're trying to solve for. And this is equal to 1. Okay. All right, so now I've got a little equation, and I can solve for the sine squared part. So I'm going to square 1/7, right? So in order to do that, I would square the top and square the bottom. Right, and then that's going to be 1/49. So I'm just simplifying the left side. All right, and now the left side is as simple as I can get it. So what I'm going to do then is I want to get this sine squared by itself on one side of the equation. All right, so in order to do that, I am going to add and subtract the same expression from both sides. In this case, I have minus 1/49. Like so. All right, I need to go ahead and do this subtraction right here. 1 minus 1/49. These are fractions, right? And so in order to do that, subtract two fractions, I need a common denominator. This denominator is 1, right? You can write 1 as 1/1, and this one is 49. So the common denominator is going to be 49. And then, so 1 is going to be 49/49, right? Because any number divided by itself, right, is equal to 1 other than 0. All right, and so now over on the left side, I will have just sine squared t. Over on the right side, I'll have 49/49 minus 1/49. That's going to be 48/49. Okay. All right, so I have sine squared by itself on one side of the equation, right, and a number over here. And so what I want to do is use the square root property to solve that out. So if you remember back in the section on when we were talking about polynomials, right, if you had an equation like x squared equals 9 or something like that, the way you solve that was to use the square root property. X equals plus or minus the square root of 9, like that. Okay? And so you got x equals plus or minus 3. So this equation is very simple, right? It follows the same pattern. I have something being squared equaling a positive number, right? And so just like before, we would know that sine of t would be equal to plus or minus the square root of 48/49. Okay. Okay. So remember back at the very beginning of this problem, I said, hey, we drew this little angle out, and it was important that we know what the sines of the cosine and sine are, right? Remember the cosine and sine, that point is a point on the terminal side, right? It's where the terminal side cuts through the unit circle. And so since they told us the angle is in the fourth quadrant, right, we know that the first coordinate would have to be positive, the second coordinate have to be negative. And so since we have a choice here, right, we have a plus and a minus, because we did this work up front, we now know that the correct choice would be the negative. Okay, and so I'm going to write that up here, up at the top. So now we know that the sine of t equals negative square root 48. Oops. It's 48 49ths, the square root of that. All right, so we know it's the negative version of that. All right, next up is we need to make sure that this radical is completely reduced. Okay, so to make sure that it's completely reduced, right, we don't want any fractions underneath the radical. So we can see we have a fraction under there. So what we would do is, right, use the properties of square roots. If I have the square root of a fraction here, right, it's the square root of the top over the square root of the bottom. So I just split it up like this. All right, then we can reduce, right, these radicals here. The square root of 49 is 7, right, because 49 is a perfect square. And then we'll also need to reduce this square root of 48. So square root of 48, again, what you want to do is think of the largest perfect squares that go into 48. That's the fastest way to do it. So we would try 4. Does 4 go into 48? Yes, it goes in 12 times. So if you find a perfect square that goes into this number, you can use that to simplify the radical, to break it down, so that you have smaller numbers underneath the radical sign. But it actually turns out in this one, right, that 4 is not the largest one. It's okay to do it little by little, but it's just a little bit quicker if you can find the largest one. And so 9 would be the next one, right? That doesn't go into 48. The next one would be 4 squared, which is 16. 16 does go into 48. And that actually is the largest perfect square that goes into 48. 16 goes into 48 3 times, right? So we write it like this. And how that helps you break it down is that you can split this radical, right? Underneath the radical, I have 16 times 3. That can be written as square root of 16 times square root of 3, right? And then 16 is a perfect square, right? So it comes out to be 4 square roots of 3, right? Because the square root of 16 is 4, right? And so the final answer on this one is negative 4 square root of 3 over 7. And that is it on this one. We will do another video with this one. On the tests, these kind of answers will most likely be where you have to convert this to a decimal. So make sure that you are able to convert that to a decimal properly using your calculator.